Today we're going to be talking about polygons and their exterior angles. Our goal is that we will be able to classify polygons and find exterior angle measures, and we will be able to find the number of sides of a regular polygon given the measures of the exterior angles of the polygon. So what is a polygon? Here's some shapes, and some of them are polygons and some of them are not. So a polygon is an enclosed figure with all straight edges. So no curves, and it has to be closed, meaning each edge connects to another. So this first one, this is a polygon. This one, because of this curved edge, is not a polygon. This one that kind of looks like some spiky hair or fire, that one is a polygon, all straight edges. Again, yes, it's a polygon. You know it as a triangle. And this one is not a polygon because of this side here where it is not enclosed. Now there's two types of polygons. There are convex polygons and concave polygons. Convex polygons has all corners on the outside of the figure. A concave polygon caves in. In other words, the corners, or some of the corners, are inside the figure. Like here's a corner that's inside, and these corners are inside. Now let's learn the names of some polygons. A polygon with 3 sides, you should already know, is a triangle. A polygon with 4 sides is a quadrilateral. If it has 5 sides, it's a pentagon. 6 sides is a hexagon. A 7-sided figure is a heptagon. An 8-sided figure is an octagon. 9 sides is a nonagon. 10 sides is a decagon. 11 sides is an undecagon. And 12 sides is a dodecagon. Now what if it has n sides, or any number of sides? We sometimes just refer to it as an n-gon. It's just a generic way of classifying whatever number of sides. Something like a polygon with 14 sides would be known as a 14gon. So if it gets any higher than 12, you just put the number in front of gon. The sum of the exterior angles for any polygon, so all of these, any that you can think of, is always 360 degrees. Now there's some special polygons. There's equilateral polygons where all the sides are congruent. There's equiangular polygons where all the angles are congruent. And then there's regular polygons where all sides and all angles are congruent. So all all the sides are the same, and all the angles are the same. So let's say we have a regular polygon. What is the sum of the exterior angles? Well, we just said the sum of the exterior angles for every single polygon is 360 degrees, always. Well, what would be the measure of one exterior angle? We know we have 360 total, divided by the fact that a heptagon is 7 sides. So we're going to divide it by 7. So if we take our calculator and we do 360 divided by 7, we get this big long decimal. So we're just going to say 51.429 degrees. We're going to estimate. We're going to round to 3 decimal places. So what if we have this figure here? We want to solve for x. So these are all our exterior angles. They're on the outside of our polygon. We know the sum of them has to be 360, and sum means add. So we're going to add these all together. And I find that when we have this many sides, to make a list like this, to add them all up, is a lot easier than writing them left to right. So we have 2 plus 3, which is 5, plus 3 more is 8, plus 2 more is 10, plus 4 more is 14, plus 1 more, we have 15 x's. 60 plus 2 is 62, minus 5 is 57, plus 3 is 60, plus 10 is 70, minus 10 is 60, and we know that equals 360 degrees. So now we're going to solve. Subtract 60 on both sides. 15x equals 300. Divide both sides by 15. And we get that x is equal to 20. What if we know that a regular polygon has an exterior angle of 42 degrees? How many sides does it have? Well, we said if we wanted one angle, we had to do 360 degrees divided by the number of sides, which we typically represent with n. That equals 24 degrees here. So we multiply both sides by n. We would get 360 equals 24n, and then we end up dividing by 24. So a shortcut would be 360 divided by the angle. Regardless, n is equal to 15 sides. So our formula for the sum of the interior angles of a polygon is 180 times n minus 2. So what is the sum of the interior angles of a hexagon? Well, a hexagon we know has 6 sides. N here stands for the number of sides. So 180 times 6 minus 2. 6 minus 2 is 4. Oh, my bad. Sorry. 6 minus 2 is 4. 4 times 180 gives us 720 degrees. So the directions are missing for this one, but we're going to solve for x. So the first thing we need to look at is that we have 4 sides here. So to find the sum of the interior angles, we need to do 180 times 4 minus 2. 4 minus 2 is 2. 2 times 180 is 360 degrees. So we need to add up all these angles. And I'm going to write them in a list to make them easier to add together and line up all my like terms. So 2 plus 3 plus 1 plus 1 will give me 7x. 1 minus 2 plus 4 will give us plus 3, and we know that it's going to equal 360. And now we can solve. Minus 3, minus 3, 7x equals 357. Divide both sides by 7. We get that x is equal to 51. What if we know the sum and we want to find the number of sides? That means 1,440 would have to be equal to 180 times n minus 2. And we're going to solve this. Now, technically, you could distribute the 180 into the parentheses, but a shorter way would be to divide both sides by 180. Those would cancel out. 1440 divided by 180 is 8 equals n minus 2. Therefore, n has to be 10. And we know that this is a decagon. Next, we're going to find the measures of the interior angles of the regular polygon. Then find the measure of one interior angle. So since it's a heptagon, we know that has 7 sides, so the sum would be equal to 180 times 7 minus 2, which when we type it in our calculators will give us 900 degrees. Now, to find one interior angle, there's 2 options. Option 1 is going to be easy because we already know the sum. Option 2 is going to be easier when we don't have the sum handy. So, since we know the sum is 900 degrees, since it's a regular heptagon, we know all the angles are the same, so we're just going to divide this by 7 to give us 128.6 degrees. Option 2, if we don't know the sum, instead of calculating it, we can use our exterior angles. We know the sum of the exterior angles is always 360. Divide that by 7 since there's 7 sides. That'll give us 51.4 degrees. Since the interior angles, so this, and the exterior angle here, ultimately form a line, we know that an interior plus an exterior equals 180. So we can do 180 minus 51.4 degrees, and that will also give us 128.6. And our last type of problem. Given the measure of one interior angle, state the number of sides. So again, it's easier if we use the fact that this is an interior, so interior plus exterior is going to equal 180. So if this is our interior, we know our exterior angle must equal 30 degrees because they have to add up to 180. We know the exteriors have a sum of 360. If we divide that by how much one exterior is, then we get 12, and we know that there's 12 sides. Go ahead and fill in your summary, and I'll